as I can see that around like 400 participants have joined. So most of them are researchers, faculty members from various disciplines. So before starting the session, we just want to we request Dr. Shasil, can you unmute? Can please mute yourself? So before starting today's session, we just want to give the brief introduction or brief outline about all these 7 days, what we are going to cover. So in the day 1, that is today, we are going to cover the basic descriptive statistics. What are the graphical representations? And some case studies with the hands-on session on SPSS. So all these sessions will be covered by half the theoretical part as well as the hands-on SPSS. So in the second day, that is tomorrow, we will cover all the parametric tests, t-test, ANOVA, F-test, and other parametric tests. And day 3, we will cover the non-parametric test. And day 4, we will cover the bivariate regression, logistic regression analysis, multinomial, and all different types of regression analysis will be done, followed by the hands-on. Then day 5, we will cover the exploratory factor analysis. Day 6, this cluster analysis will be covered. And day 7, we'll cover the discriminant analysis. So all these sessions will be covered by theoretical as well as hands-on sessions. So this is a brief outline about this upcoming 7 days, what we are going to cover with the help of our esteemed resource persons. So we have resource person from various reputed institutions, from Banaras Hindu University, SGPGI Lucknow, Baba Saheb Ambedkar University Lucknow, R.K. Paul, like from ISRI agriculture field, some are from the health background. So we have very esteemed resource person across the various domains. So with this is I just request coordinator of this workshop and the manager of Science Tech Institute, Dr. S.K. Singh, to give the welcome address for this workshop. Dr. Singh.
Thank you so much, Dr. D.K. Yadav, for nice introduction about this workshop. First of all, I would like to great thanks Professor Prabhat Kumar Singh, Honorable Vice Chancellor, UP University of Medical Science, FI Etawah. He allowed to me jointly organize this 1 week online workshop on statistical data analysis using SPSS. And he assigned the convener of this workshop, Professor S.K. Shukla. He is the convener of this 1 week workshop, and there are others persons belong from that university who is coordinating and is the part of this workshop. So I think this workshop will be a grand success, and we will learn during the 7 days many statistical tools. So now, over to you, Dr. Dharmen.
Thank you, Dr. Singh, for this very useful collaboration between the Science Tech Institute and FI Medical University. So now I request before he is a man behind this collaboration, Dr. S.K. Singh, Sushil Kumar Shukla, sir. Professor Shukla is currently working as a professor in the biostatistics in the Department of Community Medicine at Uttar Pradesh University of Medical Sciences, FI. So Dr. Shukla is having the experience of more than 25 years in the field of various statistical tools for the medical professionals. His field of research is inferential statistics, health statistics, epidemiology, clinical trials, systematic review, and meta-analysis. He has completed one ICMR-funded research project as co-investigator. He has published more than 52 articles in various national and international journals. He has guided 70+ MD students in the capacity of co-guide. He is the chief editor of International Journal of Healthcare, Education and Medical Informatics. He is recognized as an editor and reviewer for the various referred and peer-reviewed international journals. So he is a man behind this, all the organizing this workshop, along with his colleagues from the Sci-Fi University. So with this, now I request the convener of this workshop, Dr. Sushil Kumar Shukla sir, to give the welcome address to our participants.
Thank you, Dr. Dharmendra. Am I audible?
Yes, please.
Okay, thank you, Dr. Dharmendra. Good evening, everyone. On behalf of Uttar Pradesh University of Medical Sciences, Sci-Fi Itawa, I would like to welcome all the participants all over India and abroad for this 1 week online workshop, Advanced Statistical Data Analysis using SPSS, which is going to be held for 7 days from 21st to 27th January 2023. This workshop is jointly organized with Science Tech Institute, Lucknow. Dear participants, I am Dr. Sushil Kumar Shukla, Professor of Statistics, UPMS Sci-Fi Itawa. At the outside, I would like to thank our Vice Chancellor, Professor Dr. P.K. Singh sir, for giving me the opportunity to organize the present workshop jointly with Science Tech Institute, Lucknow. I would also like to thank Dr. Sushil Singh, Director, Institute of Science Tech Institute, Lucknow. I would also like to thank other member of this workshop of this Science Tech Institute, Lucknow, in recognizing our medical university to organize the workshop. Dear participants, as you all know, that the selection and application of statistical techniques in research work is a challenging task. To facilitate young researchers to successfully conduct research work in line with the international standard in research methodology, the workshop is conceived with the intention to equip them with the necessary tool and applications. So once again, I welcome all the participants for this coming workshop. Now over to you, Dr. Dharmendra. Please introduce the first speakers of our.
Yeah. Thank you. Thank you so much, sir, for your nice words and the motivation behind this workshop. But now, with this, now I would like to invite the stream resource person of the day one, Dr. Anup Kumar, sir. So are you there? Can you hear me, sir?
Yes, I can hear you.
Yeah. So before starting the session, we just want to introduce our first resource person. Dr. Anup is presently working as Associate Professor in the Department of Biostatistics and Health Informatics at Sanjay Gandhi Postgraduate Institute of Medical Sciences, SGPGI, Lucknow. He has completed his PhD from Banaras Hindu University in the field of mathematical modeling of human fertility. His current research of interest is stochastic modeling, big data analytics, text mining, and biostatistics. He has published more than 20 research articles in the reputed international journals. He has delivered more than 25 talks on on applied statistics at various national level workshops. He is closely working with different types of statistical softwares for the data analysis like R, SPSS, and many more. So thank you so much, sir, for being with us and for giving your valuable time to our participants and for enriching this session. So on behalf of all the organizing committee and my own behalf, I welcome you, sir.
Okay, thank you, Dr. Dharmendra. And it's indeed a great pleasure for me to being invited to speak to such a huge number. I can see more than 700 participants are there. And I'm very glad to see such number of participants. So we need a huge round of applause for Dr. Sushil Kumar Shukla and Dr. Sushil from UPUMS Science Tech Institute that they are just promoting how to use statistics correctly and also the motive of this workshop is to also not only to tell them the theory, but also to tell them that how they are going to do the data analysis with particularly with Spss software in this through whole week. Now today what we will be planning that, because all these data analysis that we are going to discuss, it needs that to understand to all of us that what actually the data is. Once we have the understanding of what the data is, then only we can do the data analysis, and then we can talk about the advanced data analysis. So today I will be focusing on that, what do you mean by data? And then by tomorrow onwards, I hope that today's lecture will help you to understand the analysis better. So can you give me the right to share the content?
Yes, sir, please.
So I think it is visible.
Yes, sir. Yes.
Okay. So I'll be speaking on this topic, and Dr. Dharmendra already tell you people about myself. I am in this profession of statistics since 2007 and in biostatistics since 2017. So the journey of transforming myself from a statistician to a biostatistician is quite interesting, and I learned a lot that how to teach a person who are from the medical background that how to deal with the statistical calculation. Now my first question is that why do we need statistical calculation? Do you have people thought of to answer this? You can write down in the chat box also to this answer that why do we need statistical calculation? This is my question. If you are free to write in the chat box, I want to see that what is the reason behind this statistical calculation. What do you think of this question? What will be the answer of this question? Okay, to get any inference from the data, to get result, to find a baseline data analysis, RCA, to compare for the analysis, to analyze the data, to get reference, all the answers are wrong. All the answers are wrong, let me tell you. Because the thing is that we are just thinking of the consequence. We are not to check the reality, to correlate the data. Okay, just okay. Now you can listen to the answer of this particular question. Why do we need statistical calculation? Okay, the answer of this particular question is this. Okay, the answer of this question is this: variability. Now, what is meaning of the variability? Look, whenever we measure something and the result which we are getting, if those results have got different values, it means we are measuring the temperature of our patient and we are getting different values. We are measuring the hemoglobin level of the patient, we are getting different values. What if we are not going to get the different value? If there is no variation in the thing when we are measuring it, we do not need statistical calculation. We need statistical calculation only when variability is there. So whenever this whole statistics is going to explain why this variability is there. Okay. Now, to understand this thing, we have to understand that what are the sources from where the variability come. Whenever we do experiment and we collect the data, we measure something and we just note down the value. So we in this sense, I'm saying that we collect the data. What are the source of variation? Okay. So there are three sources of variation: conditional factor of interest, measurement process, and experimental material. Just take a simple example to understand these three. We are just measuring the blood pressure of the patient. Okay, the patient is coming to the routine OPD into the endocrinology department, and the resident who was sitting over there, he just inquired them that just first go get your blood pressure note down from the nurse who was sitting outside, and then come to with me with the file. So what happened that the particular fellow go to that particular person, and the nurse is just measuring the blood pressure. She's just noting down the blood pressure on the slip and giving it back to the patient, and then the patient moves to the doctor or the resident. Now, the variability may be there because of the conditional factor, because of the factor. The factor is that the patient is hypertensive or not. So this is the conditional factor. Okay. So this is the factor whether the patient is hypertensive or not. So because of this, you have got the variability into the person who have got hypertension. Obviously, his blood pressure are going to be on a higher scale. Okay. And the person who do not have got hypertension, he do not have got any kind of, his blood pressure will be into the normal range. Now, the second factor is that how you are measuring the blood pressure of the patient, whether you are following any strict protocol to measure the blood pressure of the patient. The patient is rushing to the nurse and just says, just do my check my blood pressure, and the nurse is just checking the blood pressure. This means she is not following any measurement process. She is not following any protocol to measure the blood pressure of the patient. So because of this also, the variability can creep into the data. And third one is the experimental material also. Means you are measuring with a electronic blood pressure machine or some manual blood pressure machine. Because of that also, the variability can come into the data. Now, as a statistician or as a data analyst, when you analyze such data, you have to understand that there is variability into the blood pressure of the patient. Now you have to think what are the factors are there because of this variability is there. So one factor is obviously the patient have got some disease, some factor, conditional factor with him, but these two are also can be the factor because of which the variability can be there. Now, when you do the data collection, what you have to do? You have to keep the variability due to the measurement process and experimental material is small. Okay, then only the experimenter has the better chance of seeing the differences or seeing the variability due to the condition. So this is very important for all of you to understand that whenever you are just measuring something, you have to follow a strict protocol. You cannot change the protocol of measuring the blood pressure. The device by which you are measuring, that should be same or almost similar kind. And then only you can get a blood pressure in a very nice way to analyze. Okay. So because of this, these are the sources of variability. Now in statistics, we define three kinds of variability. What are those three kinds? One is the, we can say, planned systematic. Okay. Planned systematic variability are of three kinds. One is planned systematic, means that is coming out of because of a research question. We say that the blood pressure of the patient will be high. If the patient is hypertensive, his blood pressure is going to be high. So this is something that we want to check. This is something that we are planning. Or we can say the patient who is diabetic, his blood pressure is also going to be high. So this is something that our research question is there, and this is what we are checking. Another kind of variability is chance or random. You measure your own blood pressure 3 times and you are going to get 3 different values. So this kind of variability is chance or the random error, and these errors are very close to each other. So we have to detect whether this variability is, and third one is the unplanned systematic. Sometimes what happens, we are just thinking that blood pressure can be high because of the hypertensive patient or because of the age of the patient, but there are some other factors or also confounders which are also sitting over there, because of which the blood pressure can be high. So this unplanned systematic is also a third kind of variability. So this particular slide is all about that whenever you are collecting data, you have to consider all these points, that whenever we are collecting the data, we want to do the statistical calculation because data have got variability. Now we have to understand what are the various source of variability. Okay, and we try to minimize point number 2 and point number 3 here in these 2 slides over here. Okay, we want to minimize these 2 so that this we have to minimize these 2, otherwise we will be in difficulty. And these planned systematic is something that is coming into our research question. Chance or random is something that we do not have any control over it. And unplanned is systematic is something, still the variability is there, but it is not planned into our research. So some confounder is sitting over there. So we have to think all these when we are writing our results after doing the data analysis. So keep these slides into your mind. Now, this is another very important slide to understand what actually we do in statistics, that we have a target population. Just you can think of all the school children in the United Kingdom, and they may be many millions. What we want, to know, you can see the research question which is written over here. We want to know that what proportion are with asthma in this population, and this proportion is a population parameter, means all the school going children and what proportion of them are asthmatic. We need to estimate this proportion. So what is the idea, that take a sample, okay, from this target population by some rule, by some method, and interview them, okay, and in that just try to know that how many of them are suffering, having some asthma background, or how many of them have got the clean background. So by this we can estimate the proportion of asthma in the sample, and the sample value usually it is called the sample statistics. Okay, now the point is that to predict the behavior of the population on the basis of sample, data is the only weapon for us. Okay, so this is what my message is, that if you are not going to collect your data properly, okay, if you are not able to understand the data properly, whatever the data analysis you are going to do, that is going to give you the wrong interpretation. Now next is how the data comes into us. So there is something that when we measure something, then only the result which we are going to get, that will give us the data. Okay, so the science is all about measurement. Whether you are in the medical science or in the physics or in chemistry, we all, our motive is to measure. Okay, for example, in medicine we are just want to diagnose, so ultimately it is also kind of measurement. Okay, so measurement is the process of systematically assigning a number. Okay, systematically assigning a number to the object and their properties. So this is the definition of the measurement, that anyway we want to assign a number, okay, to the system or to the process or to the object of which we are working on. Okay, And further, the term testing, assessing, measuring, they are used interchangeably with each other. This is very important for all of us to understand that there are some quantities which are physical or observable, okay, like height, weight, body mass index. These quantities are in physics, methods are there to measure them, but there are some unobservable or latent variable like intelligence and personality. Even there are some observable quantities also, which is very difficult to measure. Okay. Now, the process of specifying how a concept will be defined and measured. Okay, so this is all about research, that how you can measure something. So this operationalization is always necessary when quality of interest cannot be measured directly. For example, satisfaction of the patient at the time of discharge. You want to measure the satisfaction level of the patient. You want to measure the work-life balance of the paramedical staff. So these are the things how you want to measure the IQ level of the ward boy who are working into your ward. Okay, how to measure the IQ of the boy. So all these things are there. For example, you want to select the faculty for the institute. So there is some process by which you do the selection. Okay, so this is what we do into the research also. So there are these unobservable quantities. For example, if for measuring the intelligence, we can have an IQ test, a valid IQ test. Burden of the disease, it can be measured by viral levels in the bloodstream for the patient with AIDS, or in the swab for the COVID, tumor size for the people with cancer. So these, by this we can measure the burden of the disease. So burden of the disease is also a concept how we can assess that what is the burden of the disease in that particular patient. Okay, so at the time of COVID, we all remember the city value is going to assess that. How you can measure the suffering. Okay, so measurement refers to the process of transforming the abstract into the concrete, or the process of restating concept as variables. So this is a very strong statement that whenever we are going to follow a research question, we are in the process of doing the measurement. Okay, so you should always have into back of your mind that you are converting the concept in the form of the variable. Okay, so I'm just want to share this particular slide with you, that this is what we want to measure. Okay, this is we want to measure. The reality is here. Okay, but our process, the way by which we are measuring, it is measuring the same thing here. Okay, so this particular measurement is reliable, because in whatever lab you are going to get it measured, the values are going to come very much close to each other, but this is not valid. Okay, second measurement is valid because when we take the average of all these, it is going to be equal to this. So this measurement process is valid, but it is not reliable, because as the with this changes, the values are very much scattered from each other. This is neither reliable nor valid. And if the measurement process is something like this, then we can say this is both reliable and valid. Okay, so this is all about measurement. Now once you do the measurement, after that you have got the data. Okay, so just look at this particular slide, that what is data. So you do the measurement, and after that you get the values, and that values is termed as data. Okay, so this data actually depends upon how you are measuring it. Now what actually I want to share with you before this slide is this concept. Okay. Remember these lines which are going to narrate with you, that whenever you measure something, okay, two things you can do. One thing, that you can associate a unit with it, and you cannot associate any unit with it. Whenever you measure something, after the values, for example, height, the height of the patient, the unit is there, centimeter, meter, but place of residence. So place of residence is urban, rural, no unit is here, no unit. So whenever you measure something, you can associate a unit with it, or you cannot associate a unit with it. Okay. So if you can associate a unit with it, it is called metric data. Okay. It is called metric data. And when you cannot associate any unit with it, is called categorical data. Okay. Whenever you measure something, you can associate a unit or you cannot associate a unit. If you can associate a unit, it is called metric data. And if you cannot associate a unit, it is called categorical data. Now, this metric data is further categorized into two parts. One is discrete, another one is continuous. Okay. Now, if the possible outcome of the measurement is countable, that is termed as discrete metric data. If the possible outcome is uncountable, that is termed as continuous metric data. For example, if a woman is coming to the OPD and the first question that you have asked him, that how many children do you have? What are the possible answer? The possible answer is 0, 1, 2, 3, or it can be up to 10, 12. So the possible answer you can count on your finger. So this is, and what is the unit associated with it? The unit associated with it is child. How many child? 0 child, 1 child, 2 child. So it is a metric data, and it is a discrete metric data, because before coming the patient, you know that the possible outcome are countable. But another question to the same woman, what is the height of the woman? What are the possible outcome? Can you count the possible outcome on your fingers? No, you can't. It is uncountable. So it is become a continuous metric data. Okay. Similarly, in categorical data is of two kinds. One is nominal and another one is ordinal. So if the categories, you cannot order them, so it is a nominal categorical data, and if you can order the categories, it will become the ordinal categorical data. For example, if a patient is coming to the COVID hospital, his status is either he can be on the room air, he is on oxygen, and he needs intubation. Now this is the categorical data. Now you can order this categorical data. By this category, you can order the situation of the patient, severity of the disease. So it is a ordinal categorical data. Okay, but patient is coming from rural or urban, or patient is male or female. Okay, so this is a nominal data. Got it? So this particular thing is also explained over here. You can see what is metric data. Data values have fixed unit of measurement. Yes. So it is a metric data. If data values do not have a fixed unit of measurement, it is a ordinal variable. If the order of the data values is undisputable, no, it is a nominal variable. And if it is disputable, yes, then further it is going to no or yes, and it is coming it. So data is either metric or categorical, and then further metric data is either discrete and continuous. Why I am emphasizing on this point? Because the type of the data is going to decide what analysis or what graph or what chart you are going to prepare for it to present your data. Okay. So this workshop basically is going to deal with these approaches, and statistical reasoning calculation generally uses these approaches. Descriptive statistics, which I'm going to describe today, then statistical estimation and testing of hypothesis. I think day 2 and day 3 is going to be dedicated on these point number 2 and point number 3, and then statistical modeling. So regression modeling and further cluster analysis, discriminant analysis, all these comes under this statistical modeling. So slowly and gradually, all these general approaches we are going to tell you. Now, let us focus on descriptive statistics. Okay, so descriptive statistics is something by which we are going to describe the data. That's it. The data we have collected, and we want to describe the data. How we can describe the data? So first thing is that with the help of tables. Okay. Now, if our table is the nominal data, if our data type is of nominal, so our table will be something like this. Okay. Just look at this table, how many information is there, and what mistake usually we do when we prepare the table. Okay. So in the first column, we have got the name of the variable, and then what are the various categories of the variable, then its frequency, and here at the top we have to write down total number. Okay, then on our reader will be able to understand the distribution of this category into our sample. You can also see that this hair color, so these are the 4 category. It is a nominal categorical variable, and the possible values of hair color are brown, dark, blonde, and red. Okay, and you can see that there are 95 children. So how these 95 children are distributed in these 4 category is 49, 27, 15, and 4. Okay, now to further explain it, to further describe it, this has been converted into percentage. Okay, now by this we can easily explain that more than 50% children who were born in the hospital, they are of brown color, and only 4.2% or around 4% children are there whose hair color is of red. So this is the, you can see that our ordinal data, and ordinal data you can also write down what are the various categories of the order and the frequency in front of it. You can also see that there are 2 groups and the same order, so data can be presented like this. In the bracket, you can also write down the percentage to give a more insight into it. Now look at this data. This is the data, parity or gravida of the woman. The 100 women who are coming to the OPD in a day, and you are asking them. So the first woman is responding 0, another one 0, 2, 0, like this. So this is the, you can say, raw data. Now you want to describe this data. So you have to understand, first of all, you have to understand this variable. Okay. Now this variable is a categorical variable or metric variable. So you will say that this is a metric variable because the unit is parity. What is the parity? 0 parity or 0 gravida, 3 gravida, 1 gravida. So unit is there. It is not a categorical data. It is a metric data. Now it is a discrete metric data. Because the possible outcome you can count on your finger. So since it is a discrete metric data, you can present it like this. Okay, frequency distribution of the parity. Write down the values and here write down the frequency of these values. Okay. You can also look at this example. Frequency distribution of efficacy of biodegradable stunt with durable stunt. So this is the possible outcome: 1 stunt, 2 stunt, 3 stunt, 4 stunt, unknown stunt or 0 stunt. And this is the frequency of these two categories. So you can see that this is again total number of lesion. What is the type of this data? So this data is again a discrete metric data. Now, you can also write down this cumulative frequency also. This column is the cumulative frequency and then percentage cumulative frequency. Some people also present it like this again. So now you can look at this birth weight. Okay, now birth weight is a continuous data because the possible outcome you are not going to count on your finger. Now you can see it is written in this class interval. Okay, and this class interval is something, it should be homogeneous because it is a class interval. So similar kind of children should be fall into this category. So this is how this class intervals are written over here, and how many children are born between 1500 gram to 199 gram. So only 2 children are born like this. So in this way, you can present your continuous metric data in the form of table. Okay. Now, similarly, just I shown you that how you can present your ordinal, nominal, discrete, and continuous data in the form of table. Similarly, you can also present them in the form of charts. And the first chart which are being over here, you can see it is a very famous chart, and its name is pie chart. So if your data is nominal or ordinal, means if your data is categorical, you can present it with the help of the pie chart. It is very you can also present your data if your data is categorical data with the help of the simple bar chart. Okay, now just just see the quality of the simple bar chart, that you have got a gap between the bars. The height of the bars is representing the frequency of the data. Okay, since these are the various categories, that how many number of patients who are there because of the fall, how many patients because of the crush, how many patients are there because of the motor vehicle crash and others cause of injuries. Okay, so in this way you can, so this is called the simple bar chart. If you have to compare the two categories, okay, level of physical activity and number of patients, this is the one group who are taking this much of drug and another group who is taking the, so you can compare these and just check. So this is called as clustered bar chart. Now, why this bar chart is very, very much important for you? Because if your data is discrete metric data, for that also you should prepare this bar chart. Okay, because it have got discontinuity between 0 and 1, it have got discontinuity. So for this, you should not prepare that histogram. For this, you should prepare bar chart. So that's why I am focusing on this particular aspect, that if your data is discrete metric data, for that, you have to go with the bar chart. And again, if your data is continuous metric data, for that, you can go with the histogram. So you can see there is no gap into the histogram. It actually represents the continuous nature of the data. Okay. This particular graph, it is termed as bar box plot, and this is one of my favorite chart. Why? Because this actually illustrate lot about, because the role of the table and the graph is to describe data, because we are just discussing descriptive statistics. So you can see that this box plot is describing a lot about this data. Okay, here you can see on the x-axis there are two groups. One is the control and one is the non-agiospermic long-term survival of the childhood cancer. Frequency is being written over here, and this last column is the lowest value, and this top column is the highest value. So this is box, and this line is termed as whisker. So sometimes this is also termed as box and whisker plot. Okay, here I have written box plot, but this is box and this is whisker. Now this box, the top of this box actually represents the 75th percentile. It means 25% of the people have got values more than this value. Okay, more than 120 into 10 to the power 6 ml. So 25% of the people in this group have got value more than 120. Similarly, this is called the first quartile, and 25% of the people have got value less than 50. Okay, and this is the median of the data. So 50% of the values are below this and 50% of the values are above this. In this way, the reader is going to read your box plot. So it hides a lot of information for you. Okay. Now, since we are discussing about the graph and table, and usually the table which you observe into a research article is something like this. You can see the table, and you should also learn by the end of this workshop that how you can prepare this table. So the first column is actually the variables, and the second column is one group, the third column is the another group, and the last column is actually going to tell whether there is any significant difference between these two groups or not. The first characteristic which you are going to describe is number of participants. So in the breastfed group, there are 149 participants. 67 are men and 82 are women. And in bottle-fed group, there are 182 participants and 93 are men and 89 are women. Now you can see another quality of this table, that whenever your data is metric data, unit are written in bracket. I didn't find anybody of you writing this unit so precisely into the table. You can see. So from this, the reader is able to understand that all these variables are metric data. Okay, because you have written the unit just in front of that particular variable. So this guides the reader that these are metric data. And smoking history, unit is not written. They are writing that we will just write down the number, and in bracket we'll just write down. And these are the three categories. Another one is the social class, and these are the categories. Okay, so these two are categorical data. So I'm just not observing the second and third column. I'm just observing the first column, and with the help of this first column, it is going to tell me a lot about my data which I have collected. Now, if you can see the height is written something like this, 170, and here in bracket it is written 10. Okay. Similarly, weight. For weight, it is written 70.4 and in bracket it is written 14.5. But for length of breastfeeding, now you can think of length of breastfeeding. So it is a continuous metric variable. So the value is 3.33. But here in bracket, they have written 0 to 18. Now this is the story that why they have written 0 to 18. For height and weight, they have written 170. In bracket, they have written 10. But for length of breastfeeding, they have written 3.33 and 0 to 18. Why? What the reader should or what you should interpret from it. So the interpretation is that if you assume that your data is normally distributed, if you assume that your data is normally distributed about the mean, then you should present your data with mean and standard deviation. That's it. But if your data is skewed, if your data is skewed like this, it is not normally distributed, then you should present your data with median and range or median and quartile. Okay. So similarly, this is another example. Okay. Now, you have described the data with the help of table. You have described the data with the help of the graph. Now, how you can describe the data with the help of the number? In the previous table, you have seen that if your data is categorical, simply count the data and write down the percentage. That's it. Nothing you have to do. It will give you the information to the reader. Okay. But if your data is continuous and you want to summarize the data, okay, so one very less frequently used is the mode. You can calculate the mode, okay, that which one is coming the maximum time. So the example is that these are the 22 babies which are born in a hospital in last week, and this is the type of delivery. Okay, so what is the modal delivery method? So by looking at this, that which method is the maximum number of way out of these 22 babies things are born. So by this you can present the modal value. Okay. Now this mode is not very much popular into the medicine because instead of giving the modal value, people just write down all the possible values, and in front of it they write down the pulse frequency, and in bracket they write down the percentage. Now another important descriptive statistics is median. Okay, so what is median? So median is something that you arrange the data in ascending and or the descending order, pick up the middle value and say 50% of observation are more than this value and 50% of observation are less than value. So that value is termed as median. Okay. So median is something which divides the data into two equal parts. So you can see this example which is being written over here, that if your data have got 5 individuals, 30, 31, 32, 33, 35, arrange them and you can say that 32 is your median. Okay. Now, if your data is like this, that it have got 6 instead of 5, it have got 6. So for this, you have to take 2 middle values because you cannot take one value. Okay, you have to take 2 middle value and you have to take mean of these two. Okay, so it will be 32.5 is the median of this data. Now, if you move to the next example, instead of 36, if the one person is of 96, in this case also, the median will be 32.5. Okay, Now, why I'm quoting this example? Because of this quality of the median, we should learn that when we should use median and when we should not use median. Okay. So now one more very important descriptive numerical descriptive statistics is the mean. You all know the formula of the mean, that you sum all the observation and divide it by number of observation. Since class 8th or 9th, also this formula is being given to you. But important thing is that when you should use mean and when you should not use mean. Okay. So when your data is normally distributed, then you should go for mean. Normally or close to normal distribution, then you should represent the summary of the data with the help of the mean. But if your data is skewed, okay, because of some outliers, the mean are going to get affected by it. And in the just previous example, if you calculate the mean of these two data, because of this 96, the mean is going to get escalated. Okay, so you just take one more example to understand that. You go to a village and ask the average income of the villagers or the household in that village. So in that village, if there are 50 household and you just start measuring the monthly income of these 50 household, you just inquired. So some of the household is responding that you evaluated 5,000, 7,000, 3,300. Like this, the observations are coming. But there are some houses for which the median is around more than 1 lakh. 1 lakh. Okay. So these 5 households are there whose annual income is more than 1 lakh. Some of them is of 2 lakh. And when you calculate the mean of this 50 household, you are going to get that average income of each household is 35,000. What the people will understand that this village is very much rich and very much successful. But if you arrange all the data in ascending or descending order and tell the median, so median is around 7,000. So you will say 50% of the people are living below 7,000. And with the median also, you can also tell the quartile that 2,000, that 25% people income is less than 2,000 and 8,000 is the third quartile. So you can say that only 25% people are above 8,000. What is mean? Mean is 35,000. So it depends upon the data that which numerical summary you should present. So if your data is skewed, you should go with the median and quartiles or median or range. And if your data is not skewed, it is normal, then you should go with median. That is what also I'm telling in this example. Length of breastfeeding. Length of breastfeeding is not normally distributed. So they have given the median 3.33 and also they have given the range. But for height, they have given 170 meter, this centimeter is the height and 10 centimeter is the standard deviation. Okay. So to summarize this measure of location, so you can see type of variable. So type of variable, it will be either nominal. So if your variable is nominal, you can see, you can calculate the mode, but you cannot calculate the median or mean. It is irrelevant to calculate the median or mean. If your data is ordinal, so mode you can calculate, median you can calculate, but mean you cannot calculate. It do not make any sense to calculate the mean of the ordinal data. Similarly, if your data is metric discrete, okay, so you can calculate the mode. Yes, median is calculated only if your data is skewed, or you can also go with the mean. mean you can calculate. Similarly, if your data is metric continuous, mode you cannot calculate. If your data is metric continuous, mode is irrelevant. And median or mean you can calculate accordingly. You have to decide whether your data is skewed or it is not skewed. Now, until now, we were discussing about the measure of location. Now we will discuss about measure of dispersion, that how much your data is scattered. The very simple thing that you can present is the range. Just present the minimum and maximum value of the data. It will give the reader an idea that in what range the people are distributed. Now the question is again, what if outliers are present? So if outliers are present, you can go with the quartiles. Okay, you can present your data with the help of this quartile, Q1 and Q3, and Q2 is actually median. Okay, so you can present your data with the help of the quartiles. In the box plot also actually presents these quartiles. Okay, this is the simple way to describe the quartile. Now you do not need to manually do this. With the help of box plot also, you can give the dispersion of the data. That's why I'm saying that this box plot is very interesting plot, because it describes the data. It gives you the mean, it gives you the quartiles, so dispersion of the data. So this gives you both things. Now, one more very important measure of dispersion, how data is dispersed, how much variation, how much variability is there into the data, is measured in terms of variance and standard deviation. Now, if you look at the simple mathematics behind obtaining the variance, so just look at this example. So there are 5 employee in a particular office, and their age is like this: 23, 34, 36, 30, and 29. And you want to calculate the standard deviation, how much variability is there in this data. So the idea is that just calculate the mean. The mean comes out to be 30.4. Add all these observations and divide by 5. The means comes out to be 30.4. Okay. Now, if you just measure the distance of all these observations from the means and find out average distance, so it will give you an idea about that how much variability is there into the data. Now, when you do this, find out the difference. So some of them are positive, some of them are negative. And whenever you add all these difference, every time you are going to get 0. So this is the property of the mean, that it will subtract all the observation from the mean and sum them, it will be 0. So the idea fails. Now what they do, they just square it. Square this distance, the difference between the mean and the individual data point. So they just square it. Okay, by squaring, all the negative also become positive, and then they calculate the sum, and then this, when they divide it by the total number of observation, it is termed as variance. So variance is nothing but this xi represents all the observation, the distance between all the observation from the mean, just square it, and after that divide it by total number of observation. Okay, so this will give you variance. This is the formula of the variance. Since you did this, so you square it, so again you have to take the square root of it. Okay, again you have to take the square root of 20.24, and it will give you 4.45. So this is nothing but standard deviation. So this is the relationship between variance and standard deviation. Again, you have to remember that if your data is nominal, you cannot calculate the range, you cannot calculate the interquartile range, and you cannot calculate the standard deviation. Okay. If your data is ordinal, you can calculate the range, you can calculate the interquartile range, but you cannot calculate the standard deviation. Similarly, if your data is metric, either it is discrete or continuous, you can calculate the range. You can go with the interquartile range if your data is skewed, and you can go with the standard deviation if your data is not skewed. Okay. So the summary of this talk is that, again, I reiterate it, that if your data have unit, you will say yes, it is metric. Data have unit, you will say no, it is categorical. Categorical data is percentage in terms of number and percentage. Metric data is presented in terms of mean, standard deviation, or median with quartiles. Now, when metric data is presented with the help of mean and standard deviation, if your data is normally distributed. When your data is presented with the median, if your data is not normally distributed, it is a skewed data. Okay, then you should go with the median and quartiles. I have given the example of this income data. Okay. So I'm not going to discuss my further slides, because I have to also discuss something on the Spss also. So at this particular point of time, I would like to invite few questions from this lecture, and then I will go for the practical session.
Hello, sir.
Yes, yes, please tell me.
I have one question. So you are using mean and standard deviation. Why not standard error?
Standard error is something different from the standard deviation. Okay. Standard error is, I think in the tomorrow lecture, they will also explain you in detail. But standard error and standard deviation are two different concepts, two different things. When you estimate something, so you are going to get a, for example, just the example which I was showing, that you want to estimate what proportion of children are suffering from asthma. You just recruited 100 children and interviewed them, and you find out the value comes out to be 19. Okay. Hello.
Yes, sir. Yes, sir.
And if somebody again, if somebody else is going to do the same thing, or if you are going to measure the average weight of the children of class 5th, so you are going to get some values around, say, 25 kg. And if somebody else is going to do the same experiment, so he is going to get another value. He may get 20 kg, another he may get 22 kg. So the estimates are changing as per the sample. So in this case, what is happening? You are saying that this is my mean value, and the error which is there in my measurement is termed as standard error. Here you are simply describing the data, that I have collected the data of the 50 children, mean is this and standard deviation is this. That standard error will come when you will talk about the estimation part. Tomorrow it will be discussed, I think. So you will again be with this confusion. Tomorrow the speaker will explain you. But when you are going to describe the data, you have to give mean and standard deviation given your data is normally distributed.
So I also have a okay. So I also have a question, sir.
Yes.
Whenever there is a table and median is described, and you also showed a table in which there was a median and in brackets there were some number which were mentioning the range. But later on you said that usually we should describe the interquartile range. So what is the ideal way to mention in the brackets, interquartile range, or the complete range?
If your data do not have much outliers, so you can go with the that range. But if your data is containing outliers, then you should go with the interquartile range. Means in that case, the maximum or
Can
the
you simplify your statement, sir? Yeah, it will.
Yes. I'm simplifying my statement. If you heard my example of that income, if you are going to say that 7,000 is the median value. The range is 500 to 2 lakh. Another statement, 7,000 is the median value, and first quartile is 5,000 and third quartile is 8,000. Now, reader in which have got reader got maximum information?
I
first
think
one or second one?
First one, sir. If he is being told that, shouldn't he come to know that the range was so much variable?
No, the second example, because he came to know more than 8,000, only 25% people are there.
Okay, sir. So it means if there are more number of outliers, then interquartile range should be used.
Yes. In that case, you should go with the interquartile.
So more outliers, interquartile range, less outliers, the whole range should be given.
Even one outlier is there, you should go with the interquartile range, because that outlier is going to, because what is the range? Maximum or minimum value? Outlier is there, so it will just tell that this is the maximum value.
It will confuse the reader, basically.
Yes. So it is better to go with the not interquartile range. It is better to go with the quartiles, because it gives more information. It describes the data better.
But sir, in that case, shouldn't the table be mentioning that what we are talking about? Because like in that table, they did not clarify what they are giving.
No. Actually, they have just written that you should write down the star, and at the footnote, you should write down what actually it is.
Understood, sir. Understood.
Yes.
Thank you, sir.
Sir,
Yes.
and you talked about the nominal distribution. So if there are about 10 data, I will know the outliers. But in case there are a huge number of data, how should I know how should I know that my data is having a bell-shaped curve, or whether it is skewed data? What are the ways in which I can test?
I will answer this question into the practical session. That because in Spss, I will tell you how to test the normality of the data. Valid question. I will answer into the practical session.
Sir.
Sir,
I have a question.
Yes.
So how do we summarize any data which is on a Likert scale?
The Likert scale data is basically the ordinal data. Okay. So you should go with median, and median is the best way to compare between two groups. Okay. Yeah.
So median along with the interquartile range.
Yes.
Median
not interquartile range. I am not preferring interquartile, because interquartile range is again simply the difference between Q3 and Q1.
Yes,
you should give median, and with median you should give that Q1 and Q3.
Okay. Thank you, sir.
So can you again explain the ordinal data?
Yeah, even I want to know about the ordinal data.
Sir, please explain about skewed data.
Yes, I will be explaining skewed data into the practical session. Now, ordinal data is something, the data do not have any unit, but it have got ordering. It is a categorical data, but the categories are, you can order in the categories. But what is the difference between these categories that you cannot elaborate? Okay. This is the ordering, means what I tell you, when you measure something, you can associate a unit with it, or you cannot associate a unit with it. If you cannot associate a unit with it, it is a categorical data. Now, if the categories can be ordered, it has some sense in ordering the categories, then it will become the ordinal categorical data. Otherwise, it will be the nominal data. As I have given the example, when the patient comes to the COVID hospital, what is the status of the patient? The patient is on the room air, the patient is on the oxygen, or the patient needs intubation. Now, these are the three categories. But by knowing these three categories, the doctor have an idea that what is the severity of the patient who are coming to the OPD or into the COVID hospital. Okay, but the same patient, whether is coming from urban or rural, this do not have any ordering into it. Okay, so this is the meaning. Categorical data, categories have got some order. But how many? What is the actual difference between these categories that you cannot tell?
Excuse me, sir.
Yes.
So you give an example of like number of children a patient is having. So, sir, that doesn't exactly have any metric unit as such. So how is it?
It have 2 children. How many children? 2 child. It have got a unit with it on its back. How many child? 2 child. How many stunt? 3 stunt. Okay.
Sir,
so this, yes.
Sir,
Excuse me, sir.
they're not very clear about the variance and standard deviation and the difference. I couldn't get it properly, sir.
Did you understand the variance?
No, sir, not very clearly, sir. The mean
Okay.
and what you have explained, I heard, but not very clear, sir.
Okay.
The same question here, sir. In a standard deviation,
Hmm.
should the denominator be n-1 because the sample size is less than 30?
No. This n-1 will come when you are talking about unbiased estimation of the standard deviation. And now when we are talking about the
Well, we have
estimating,
read this several times that if the sample size is less than 30, the denominator should be n-1.
no, this is a wrong concept. This is a wrong concept.
Okay.
This is really a very wrong concept, and let me tell you that today we are just we are in the process of describing the data. What you are telling actually is that look what we are doing. We are just taking a sample, and on the basis of sample, we are estimating the mean and standard deviation. Okay.
Yes.
Now, as the sample will change, this mean and standard deviation will change.
Definitely.
Third sample, the mean and standard deviation will change.
Yes.
Okay. Now, the thing is that this, what is the unbiased statistics of mean? So it is nothing but just mean. Mean is the unbiased measurement of mean. But for variance, you have to, instead of dividing by n, you have to divide it by 1 upon n-1. Then only it will be unbiased statistics of variance. Okay. So when you are just describing the data, you should just simply go with 1 upon n. That's it.
Okay.
Excuse me, sir. Can you explain the range?
Sir,
Range is maximum and minimum value. That's it.
Sir, regarding mode,
Sir,
excuse
one
me, sir.
question.
Yes.
Regarding
Sir,
the mode,
can I go ahead?
for continuous data, continuous metric data, is it possible to find the mode?
No.
It was, but
it is possible. Formula. No, it is possible.
Yeah.
It is possible, but it is irrelevant.
But it's possible. I think in practically it is possible, but through software, I think it's not available.
No. It is possible to, you can get the mode of the continuous data, but it is irrelevant. Iska koi zarurat nahi padega. That is what the message is.
Sir, the number of children, if you take the number of children, for example, it becomes metric discrete data, right?
Yes.
But if you take a fertility rate like 2.1, 3.3, it becomes, it is not discrete, it becomes continuous, right?
Yes, it will become continuous.
In that case, we can't take mode.
In that case, you cannot take, look, this is the rate. And to club the rate, it needs quite different, that is harmonic mean you can go with. Because when you are going to club the rate for describing the rate, you should go with the harmonic mean. What I discussed today, I didn't discuss the harmonic mean.
Sir,
can you tell about
variance.
interquartile range and whole range? When you are discussing about interquartile and whole, at that time we lost the connectivity. Can you?
I am not in favor of interquartile range. Interquartile range is simply difference between Q3 minus Q1. That's it. I am in favor of presenting your data Q3 and Q1. Do not present the difference between them. Just give the median and Q3 and Q1. You can, instead of giving a Q3 and Q1, you can give the maximum or the minimum if your data do not contain any outlier. That is my message.
Sir,
Outlier.
if there is no outliers,
Planned
then
systematic
the
variability.
distribution will be a normal distribution, sir.
Yes, again.
Can you please explain the planned systematic variability?
Planned systematic variability. Yes,
Yeah,
very valid question. You for example, you want to measure the impact of COVID vaccination on
Sir, can you explain it in terms of agriculture? Actually, I'm an
yes, I
agriculture.
can explain it in terms of agriculture.
Yeah,
if you want to measure the impact of
maybe a fertilizer.
yes, impact of fertilizer on the outcome of a crop. Okay.
Yeah. Okay.
So you are just giving a different level of fertilizers into different blocks.
Yeah.
And you are measuring the outcome at the end. At the end, okay. The size of the field and everything is there. So you are measuring the variability. You are measuring the variability because this is planned. You are planning. इसमें 50 gram देंगे, इसमें 100 gram देंगे, इसमें 150 gram.
Sure.
Okay. So the variability is planned. But sometimes what happen? Not only the fertilizer is there because by which the output is there.
Okay.
The quality of soil, how much irrigation you are giving to this. Maybe one land is getting more irrigation and another two land is not getting so much of irrigation. One land is under the shadow of the tree, another two land is not under the shadow of the tree.
Or maybe soil fertility
so variability can creep in because of the unplanned systematic.
Okay.
So
Sir, can you give some example
Thank you,
of standard error in terms of clinical data?
Standard error, boss, something is like that. I tell you, this standard error is coming so many times. Let me just.
तो पेपर्स में तो ज्यादा स्टैंडर्ड एरर ही यूज होता है ना सर?
नहीं मैम, मैं उसको क्लियर कर दूं तब आप लोगों से फिर बात करूं क्योंकि ये बड़ा ही
So, but we can remove the outliers, है ना?
Yes, we can remove the outliers given that our information doesn't we doesn't lose the information. A minute, I have got that particular. Just let me share one figure with you people. Yeah. Can you look at this particular figure?
Or sir, we use the standard error for population parameter.
Yes, sir. It is visible.
Let me explain this figure. Then
yes, sir. It is visible.
Okay. You can just think of that. This is the employees of institution, and measure. Just unmute mute yourself. You want to measure the what you can say average. Height of the employee of your institution. Okay. Now the question is that you take a random sample of these are the 1,000 employees, and you take a random sample of size n, of size 50. Okay. From this 1,000 sample target population, you take a random sample of size 50, and in that you measure the average, and it comes out to be 152 centimeters. If you again repeat the same experiment, the average height comes out to be 161. If you again take the the average height comes out to be 159 centimeters. Now you can see that as the sample will change, the average height is going to change. Okay. So this means from the population, you are taking the sample and you are estimating the average height. You are estimating the height. But you, while doing this process, you are committing an error. Because the actual sample size, it can be 152 centimeter. But when you are doing it, comes out to be 161 centimeters. So actual samples, you are committing an error and you want to measure this error. You want to measure this error. Okay. So this error, do you understand what error you are coming? You are doing a sampling error because yes.
So what we should understand actually is that standard deviation, suppose we have a sample or we have a population, standard deviation is a measure of variability.
Yes.
Around the mean in that particular population. Yes. And standard error is if we repeat such experiment multiple times, how much will be the variability in the different means we get?
Yes.
That is the measure of the standard error.
Yes,
So
that is actually.
there are two different things. So in most of the papers, standard error is depicted because they want to see whether our experiment was reliable or not. So we have to depict standard error also. But for our particular population in which we are working for descriptive work, we need standard deviation also.
When you are, yes, that is what actually I want to tell. When you are in the phase of describing the data, when you are preparing the you can say baseline table of your data, at that time you should not go with the standard error.
Yes.
At that time you should simply give the mean and standard deviation, because it will tell in your sample how much data is varying. And this standard error actually is measuring that what you have measured, how much error is there. Okay, so this standard error actually measure what is the error into your data. So again, tomorrow this standard error will be discussed and it will be explained to you people.
Sir, hello.
Yes.
Excuse me, sir. Standard error actually it defines the external validity of the data or not, like whether the data is...
Standard error actually measures the you can say precision of the estimate. How your estimate is, how is precise your estimate is. If there is a lot of variability into the standard error, it means your estimate is not precise.
Okay.
Sir, excuse me, sir.
How we can find the pooled sampled standard error?
Pooled sampled standard error.
No, sir, for which data we use? Is it audible, sir?
Yes, again, which data?
Sir, for which data, like you already taught about nominal data, ordinal data. So for which data we use box plot, sir? Whisker plot.
Box plot, we can go for this metric data. We can prepare it for the nominal ordinal data. For these two, we can prepare the box plot.
Okay, sir.
And it will be better if our data is skewed. Box plot is the better representation. But if your data is continuous, no need of the box plot, because we think that our data is symmetric.
Excuse me, sir.
Yes.
Sir, I have... Hello, am I audible?
Sir, please explain the variance and the standard deviation. I was still confused, sir.
Yes, variance and standard deviation. Variance is the measure of all the points from the mean. You just square it and then you just take the average of it.
What is the significance, sir?
By this you are measuring that how much variability is there into the data. आपने क्या किया? आपने सारे observations को mean से distance निकाल लिया. अब देखना average distance कितना है.
सारे values का. जी sir.
सारे values को you just subtracted from the mean. And जब आपने sum किया तो 0 हो गया, तो इसके लिए आपने क्या कर दिया? Square कर दिया.
Yeah, sure, sir.
And square करने के बाद then you have taken the average distance. तो आपको पता कि data में कितना फैलाव है, means how much data are deviating from the mean. What is the average distance of the data, squared average distance of the data from the mean. तो इससे आपको पता चलता कहाँ पे data means के ज्यादा पास है, कहाँ पे data means से ज्यादा दूर है. अगर variance ज्यादा है, इसका मतलब ज्यादा दूर है. Variance लेकिन क्योंकि आपने स्क्वायर किया था, because you have squared it, so again you have just taken the square root, उसको उसी में लाने के लिए. So this is the difference between variance and standard.
Excuse me, sir.
Yes.
And standard deviation, sir?
Excuse me, sir. Sir, actually, I have 50 total patient sample. Actually,
Listen, let me explain something on the SPSS also, because it is very important.
Sir, one last question, sir.
Yes. Yeah, we can
Sir, I
take
have
questions in the
50
last
total samples.
after this
I will take
because we are running late.
The last.
We will take
The
questions in the last.
one, sir.
Sir, how does standard deviation
Sir, I
affect
have
validity?
50 samples.
Please,
Among which,
yeah, I will answer your question. I will answer your question.
Please put your questions with us, and after this hands
I will answer the question.
We will again
because the time is running now. So one of the motive of this talk
Sir,
is
one
to
last question.
No, there is no problem now. You have time. Don't worry. And I think more of your questions will be short out during the hands-on session. So please continue, sir, with the hands-on.
Okay, so can you give me to share this? Yes. Share. So I just simply assume that you people are aware of this SPSS software, and what I will do actually is that first of all I will show you a data. Let me check which data I should show you. I just want to I want to share a data with you. I do not have that data right now here with me. Okay, so my slide and this is do not have that data. Just bear with me. The data which I want to share with you people is work followed by text document. No. Let me check this data. Means I didn't have any idea about this data. So this data is actually, you can see this is the name of the baby. This is the, you can see the identification of the baby, then mobile number of the baby. So I should hide it. Okay. Then it is inborn, whether this particular patient is inborn or sponge IVF. So this gestation age and then gestation age week. Okay, so this is the variable, and this variable is the gestation age in week. Okay, and there are other variables also. There are a lot of other variables also. Now the issue is that how to prepare the summary chart of this data. Okay, so what we will do, how to describe this data, or what I would like to tell that I want to describe just I'm taking this this information and I'm saving this to desktop and naming it test. Save. Don't save. So on the desktop, I have got a data. Its name is test into the Excel, and this data have got some. This data have got some identification number, one variable which name is inborn, and one more variable is spont or IVF. Okay, and then another variable is date of. So I will not take this. I will simply deleting. Then age at admission. This is the age of the baby at admission in days. This is the gestational age of the baby. Birth weight of the baby in gram. And whether the baby is AGA or SGA, and whether the steroid is given to the baby or not. So yes or no. So I will simply call this data into the SPSS, and I will be describing these variables in SPSS. I will just simply try to prepare the summary of these variables into the SPSS. So this is the idea. So this data is on the desktop. So I will simply open SPSS. So this SPSS is actually when you open it, it will look like this. If you people just I've shown you the Excel, so you can see that if you on the data view, it is simply the rows will be 1, 2, 3, and the columns will be VAR, 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 VAR. Why it is? Because when you will see in the rows, the numbers are there, but the columns, these are the variables, the things which we are measuring. So variables are here. Okay, so that is what it is showing here. But it have got another beautiful tab at this left bottom, variable view, and in the variable view the things are like this. Okay, name, type, width, decimal, label, values, missing column, something like this. Okay, now what is the meaning of this? I will explain. First of all, I will try to call that data which is available on the Excel into this file. So you should go to the file and import data from the Excel. Click on Excel and then go to the location of the data. So data is at the desktop, and the desktop it is test. Okay, and then click open. So when you will just do it, it will ask you certain question that what are these variable are, and just scroll it and just click OK. So it have just simply called that data from Excel to SPSS, and now in the SPSS I will try to describe the data. Now you can see the first case is this, the second case is this, the third case is this, and in this particular data we have got 67 cases. So 67 data of 67 children are here, and this is the identification number. So identification number, it can never be numeric. It is always yeah, it can be numeric, okay, but decimal is, you can say, 0. So CR number is in the form of the numeric, width is 0, but the level of measurement is nominal because it is a identical. This is a identity variable. So what is the label? You can write down identity, TITY, identity number. Okay, what actually it did, you can see in the data view, it is Excel kind of thing, but here this variable This is the quality of the, this is how you are describing the variable. Please don't do this. Okay. You do not want to learn, you cannot just simply, but do not do this. So this CR number is numeric. What is this? This is the level of measurement is ordinal. Okay. And here in the level you have described what it is. Another one is inborn. So here you can describe, now this inborn you can see yes or no. Okay. So what you can do smartly into the SPSS is you should convert this string into the numeric. Means you should code 1 to the yes and 0 to the no. Okay. This you can do. Now how you can do that? Just go to the analyze descriptive statistics frequency and inborn and spontaneous IVF. Just click OK. So you can see that there are 67 babies, no 50, yes 17. Why I'm doing this? Because I want to see whether some another variable is also there. Because sometimes what happens if you've written no in small no, so again it will take small no as another category. Okay. So there are only two categories. Similarly, here also there are only two categories, IVF and spontaneous. Now, the ideal thing is that you should keep this data here. This is the string, but you should convert this into the here. You should convert this into the numeric. How you can do that? Just look at this. Just go to the transform and record into the same variable. Okay. And then just select this inborn and this. Transform, record into the same variable and select inborn, and then go to the old and new values. Old value is yes. So give yes to 1 and then add it. And then again, another old value is no. Give this, you can give it 0 or 2, whatever you want. Just then continue and then click OK. So after doing this process, when you will go to the data value, you can see this is converted into 1 and 0. Okay. This is converted into 1, 0. After that, what you should do, you should change this string into the numeric and then click OK. Now, this is what? This is the, you can explain the data, WHE, whether the patient is inborn. This is the labeling of this name. And then smartly what you have to do, just click on values. And for 1, you should write down yes, add, and for 2, you should write down no. So this is the values of your numeric variable. So when you will go here, you can see, oh, one mistake I have did, that instead of 2, I should change it. I should remove. I should just write down 0 and write down no. For 0, we have no, add, okay. So this is the, you can see what, and when you click on it, it will show 1, 0. When you just want to see the value of it, it is again yes. Now you can see the difference. You can see the difference at here. This inborn is showing you the nominal, and this is also nominal, but it is a string nominal. Okay. So for further analysis, this will be helpful for doing the parametric and non-parametric. This cleaning is very much important. Okay. So you should know how to clean the data in this format. I will again repeat for this spontaneous IVF. Just go to the transform, record into the same variable, and select spont IVF. Okay. Then click OK. Now old and new values. Now what are the old values? So in the output, just let me just cancel it. Just I have to see into the, so there are SPONT, and this is case sensitive. So you have to remember IVF, SPONT. So I will give 1 to the IVF and 2 to the SPONT. Okay. Now again, just again, I will go to the transform, record into the same variable. Okay, and I will write down SPONT. I will give 1 to SPONT and IVF. It is a case sensitive, so I have to take care of this. Continue and OK. Now I have converted this into 1 or 2, that string into numeric. After that, I have to change the type from string to numeric. Okay. After that, I have to change the value. 1 stand for SPONT and 2 stand for IVF. Okay. And then click OK. And you can see into the data view that again this data is now a nominal data. Okay. Now you can see what is actually happening here. This age at admission. Okay. Age at admission. So this is the data, and this data is actually in days. When the baby is admitted to the hospital, what is the age of the baby? Age at the time of admission of the baby. So you can see data, it is written 1111 like this. But what is the this type is numeric. But what is the level of measurement? Level of measurement is given as nominal. No, it should not be nominal. It should be scale. It is a scale data. So you have to do like this. Okay, it is a scale data. Similarly, gestation age at week, it is a scale data. Birth weight, it is a scale data. AGA, SGA, steroid, again these two are string nominal. You have to convert it into the nominal the way I have told you. Now, this is your data set. Now you want to summarize this data set. So for that, what you have to do, that you should go to the descriptive statistics and go to the frequency, and in the frequency you just put all the categorical variable like this. Okay, and then click OK. So from here you can see the frequency and the percentage. So you can write down these results into your Excel sheet. That will represent that out of 67, 73% are AGA and only 26% are SGA. How many of them are taking steroid? So around 60% do not taken any kind of steroid, and 40% of them have taken the steroid. So in this way, these categorical data with the help of number and percentage, you can put it. Now, again, the question is what we should do with this metric data. Okay, so we have got 3 metric data. Now, what we should do? So in my lectures, I told you that if your metric data is skewed, you should go with the median and interquartile range. And if your metric data is normally distributed, so you should go with the median and standard deviation. Now we should check whether our data is normally distributed or skewed. For doing this, we should go to the analyze, descriptive statistics, and then go to the explore. Okay, and then select your dependent list. Okay, so I'm selecting these 3. I'm selecting all these 3 lists, and then I'm going to click on this statistics, and this is the descriptive statistics, and confidence interval for mean will also give. Okay, then I will go to the plots. So I want histogram. Okay, and here it is given normality plot with test. So I will click normality plot with test, then continue, and then in the option nothing will change, and display, I want to display both. So for these 3 variables, it will display the descriptive statistics, histogram, and normality test. then I will click OK. So when I will click OK, it is going to give all the descriptive statistics of all these three variables. You can see 8 age admission, the mean is 7.52, and the median is 4 days. Mean is 7.52, median is 4 days. Now what is the range? Minimum is 1 and maximum is 38. Okay. Interquartile range is 11. Skewness is this and kurtosis is this. As I didn't discuss skewness and kurtosis, so I've not. And you can see that, yes. So standard error is also being calculated here, but you should go with mean, and here you can see standard deviation is you should not go with this standard error. Okay, when you are going to describe the data. Now, whether we should use mean with the standard deviation or we should use median with range or interquartile range. So for that we should just look at the normality of the data. So you can see that in these three, the null hypothesis is that data is normally distributed. Okay, so the data is normally distributed, so this is rejected. Gestation age at week, data is not, this is also rejected. Birth weight, you can see it is somewhat also very much close to the rejection. You can see the histogram of age at admission. It is not normally distributed kind of data. You can see that most of the patient baby who are admitted to the hospital, their age is quite less. So this is a skewed data. Okay. Again, you can see the box plot of this. If the box plot is not symmetric, this median is not lying into the middle of it. So again, it is also a representation of that data is. You can also see that gestation age at week. This is also a skewed data. Okay. This is not normally distributed data. And similarly, the birth weight, this birth weight is also a very different kind of data. It is not a normally distributed data. So what we should do now? Again, the question is that but you can see this histogram, the birth weight is very much close to the normal distribution. So for birth weight, you can give mean and standard deviation, but for another two, you should not give mean and standard deviation. You can see there are lots of outliers which are sitting over there. Now with this, again go to the analyze descriptive statistics. Here you can see frequency, or you can go with this explore. Okay, and show the statistics only. In statistics, I want percentile because I want Q1 and Q3, so I click the percentile. I want the outliers, so I also click the outliers and then click continue and then click OK. Okay, so it is going to give me the percentile. You can see the quartile for age at admission 1. It means 25% of the patient have 1. What is the median? 4. 50% of the patient when they are admitted to the hospital, their age is 4, and 25% of the patient when they are admitted to the hospital, their age is more than 11. Similarly, gestation age at week 34 is the 34 week is the 25% of the babies are born below 34 week, and only 25% of the babies are born above 37 week. Similarly, for birth weight, 25% of the babies are born with 167 years. So this is how the people is reading, describing your data. The mean and standard deviation you can find out from here, and percentile you can find out from here. Now these are the extreme values. These are the extreme values at age at admission. Serial number 67, 23, 60, 61, and 26. You can see these are the extreme values for your highest extreme values. Now you can just remove if it is going to affect your data analysis. Similarly, the lowest 5 lowest value. Similarly, for gestation age, 5 highest value and 5 lowest value are being given over, and birth weight 5 highest value and 5 lowest value are being given for you. Now from here you can decide as a principal investigator that what is my outliers and whether we should keep it for further, we should keep it for analysis or not. Okay, so this is all about describing the data. And if you go to the graphs, and here you can see I have discussed the bar chart, simple bar chart, define. I want to prepare the bar chart for this. Okay, so it will just simply give me the bar chart whether the patient is inborn, count is here. Similarly, if I want to prepare the pie chart, spontaneous, because it is only 2 categorical, so pie chart will be something like this. But if there are more than 2 categories, so pie chart will explain more about it. And one more graph is box plot, simple box plot, just define it. I want to see the box plot of age at admission. Okay, this is the variable age at admission. I want to see its box plot. And I want to see whether the age at admission is going to depend upon whether the patient is inborn or outborn. So you can see that this is the box plot for these 2 categories also. Graphs in this way, in SPSS, graphs are being prepared for you. Histogram is there. If you want to prepare the histogram for birth weight, just click OK, and it will give you the histogram of birth weight. Okay, so in this way, you can just go with preparing the charts and graph outliers. You can check whether your data is normally distributed. For that, again, I will tell you, go to the analyze, descriptive statistics, explore, and in explore you should go with the statistics, then click, and then go into the just cancel. Just a minute. Cancel, reset. I am just taking this variable and I am just going to the plots. Now in the plots, you can see normality plots with test. Okay. And then I will click OK. So what it will do, actually, it will just test for normality there. So there are 2 tests. One is the Kolmogorov-Simbrov test, another one is the Saproville test. These both tests, the null hypothesis in these both tests is that my data is normally distributed. And if it is coming insignificant, so you can say that null hypothesis is rejected. It means your data is not normally distributed. So if your data is not normally distributed, for this you should present median with quartiles. Okay, so this is the way you should present your data. Okay. So I will stop here, and again I will invite the question for this presentation if any confusion is there. Actually, for testing of homogeneity, you should go with this mean, and then in the one-way ANOVA. And if you want to just want to test whether the gestational age at week have something to do with the spontaneous IVF, and then go to the post hoc. And here in the post hoc, you want to test whether your equal variance is assumed there or not. So how to do the post hoc into this SPSS? And so test of homogeneity is mean both the data are coming from the variance is both the variance is equal in both the data set. So this is the way to test the homogeneity, and I think there is no direct way to test the homogeneity of the data into the SPSS. I may not be sure, that how to test the homogeneity into the SPSS directly. The formulas are there. I didn't discuss that, but request Dr. Dharmen to do it in some another session. Right now, I'm not remembering how to do this test of homogeneity into the SPSS directly. It may be there. I have got some another session, so I will try to explain in that. Any another question? Yeah. Yeah, anybody can unmute and ask the question. So regarding this practical presentation. Am I audible? There are lots of questions actually. And sir, you are running too fast. Sir, can we make nomogram? No, nomogram is very difficult to. Dr. Dharmen, can you let the participant to unmute and ask them question? So the question is that how to convert this. I'm doing it for this AG and SGA because you can see when I'm just clicking on this number, this is changing numeric to label. This is changing, but this AG and SGA is not changing. Okay, because it is a nominal variable. It is a string nominal variable. Okay, so we have to convert it into the numeric. For this, what we have to do, just go to the analyze frequency and reset. I want to just see what are the outcome. So AG and SGA. So I will code AGA with 1 and SGA with 2. So I will go to the transform, recode into the same variable. I will reset it. AG, SGA, old and new value. So I will give AGA 1, add, and SGA 2, add, continue, and OK. Now what it will do, it will convert this AG and SGA into the numeric variable. After this, I can convert this into the numeric. After this only, remember. Okay, and then in the label, I will go here in the values, I will go 1 and I will write down AGA, add, and 2, I will round SGA, add, and I will click OK. So you can see now it is AG and SG again, and this is a numeric, this is a nominal data, numeric nominal data, we can say. So any question? Means you can unmute and ask the question. So the question is that which normality test we should use. So when you will go into the SPSS, it will actually give you both the result, but this KS test is for more than 50 sample, and SAPRO will test is when your sample size is less than 50. This is not a rule of thumb, but yes.
Excuse me, sir.
Yes.
Sir, what is string variable?
String variable, what is string variable? When the values you are writing in A, B, C, D. So it is a string. You can see the last stroid. It is not numeric, because when I'm clicking on this A1A, you can see things are changing, but it is not changing.
because its characteristic is that it is a string. Okay.
So we can say
So
it is
that-
alphabet. Can we say it is alphabet?
Yeah, alphabet. But it's in mathematics, we used to say it is.
I mean, easy way to remember.
Sir,
It's
taste of
alphabet.
normality, sir, please tell us once again from where we get the taste of normality.
Okay. Yeah, just
Sir, also, sir, I wanted to know how to decide
Normality
sample
test, sir.
size. Sir, how to decide sample size?
Sample size, how I can tell you in this short duration, it needs another 1 hour lecture to explain you the sample size.
That is another topic.
Sir,
That is the another topic.
Sir, please explain the normality test again.
Yes, for normality test, what you have to do, go to the analyze, descriptive statistics, and then go to the explore. In the explore, you select the metric variable. Okay. Here in SPSS, it is termed as scale variable. So select any metric or scale variable here, and then go to the plots. In the plots, just tick normality plots with test. Okay. And when you click continue or okay, it will give you the test values for the normality plot. Now, how to explain this? The null hypothesis of this test is this particular variable is normally distributed. This is the null hypothesis. And if it is rejected because its value is less than 0.05, so
Yes.
you will say that this is not normally distributed. Then the decision is that for this, you should present median with quartiles.
Sir, is there any best way to change the
During
normality?
presentation, explain that
Sir,
if
how
you're
to plot
using
trend
Likert
line?
scale, how we can analyze that? If you're using Likert scale.
Likert scale, how to analyze that? This Likert scale is something which is just a way of measuring the attitude in 1 to 5 or 1 to 10 point of view. Okay. So for that, you can also present the median and quartiles.
Sir, somebody asked a question about homogeneity in between. But my question is very simple, like where to apply the, like when do you really need, because we can definitely ask our statistician to help us.
We need when we are going to compare, when we are comparing the two different groups. Okay. One is case and one is control. So when we are doing it, you can see there are assumptions, your variance are equal in these two groups. Height into the children who are drinking the Bournvita, height into the group of the children who are not drinking the Bournvita. Assumption is that the variability of the height in these two groups are equal.
Okay, sir. So to test whether the variability is equal in these two groups, we need the test of homogeneity.
Yes. We need the test.
Okay.
Dr. Anup.
Yes, sir.
Here also we can.
Sir, how to plot trend line?
Sorry to interrupt. Here somebody has asked to how to do the check the homogeneity of the variance. No? Here in ANOVA, you can click on option.
Yes. In ANOVA. Yes.
Click
Where?
Option. Yeah, here is the homogeneity test of the
homogeneity test of variance.
By this we can
Thank you, sir. Thank you. Actually, I was just remembering whether it can be done directly test cases or not. Yes. Thank you, sir.
Directly also we can do with the F test, no variance test.
Yes.
But by ANOVA also we can do this one.
Yes. Definitely. Thank you.
Sir, is there any best way to change
how to
non-normal data into normal?
Trend line?
Sir, it would be better if we go systematically. It's getting complicated. Everybody is asking questions from a lot of dimensions.
Yes. You ask.
Sir.
Yes.
Sir, can you share this data so that we can practice ourselves?
Yes, I can share. I just
This data or any other data. So whatever you have told today, explained today, we can practice ourselves.
Sir,
this data, please. By mail. So that.
Sir, please share in the chat box. Participants can directly download it from that.
Sir, when should we?
Excuse me, sir. But not able to open it.
Sir, SPSS software trial version is not opening, sir.
Dr. Dharmen.
Yes, yes.
Please give the details. Give the data set and PPT.
Hello,
Okay,
sir.
no
Sir,
problem.
we do have data, but SPSS trial version we are not able to open, sir.
Excuse me, sir.
Yes, please tell me.
I want to know when do we use like post hoc test?
Post hoc test is used when we are saying that our data is look. Hoc is something when we are just looking at that our data are equally distributed, means there is no difference into the groups. Oh, then there is no need of going for the post hoc. When there is a difference, then we want to see that how much difference is there. Then we are going for the post hoc test.
Okay, thank you, sir.
Excuse me, sir. So please tell us that how we can use different type of tests and where we have to apply this. Sir, please can you tell us
I
Oh,
one by
think
one?
next in the next two session you will get the answer to this question, because testing of hypothesis, parametric and non-parametric, day 2 and day 3 is dedicated.
Kindly repeat the post hoc test again. Post hoc
Are we getting
again.
the recording?
Can you tell the basics of SPSS?
I told a little bit basic of SPSS in the practical session. That how you can if you remember, I told you that how this SPSS, when you open, how does it look like? It have got a data view just like the Excel. It have got a variable view in which you can explain the variable. How you can explain the variable, that is also is being also explained to you. And when you click, there is one more window open that is termed as output variable. The beauty of this output variable is that you can copy from here and paste directly to your Word file also. Okay, so
Hello. Good evening,
yes.
sir. Excuse me, sir. Sir, so what does QQ plot represent? Data editor.
Sir,
Yes.
sir,
Where is this data
can you explain
editor?
this post hoc? When to use post hoc again? Again, kindly, please. Post hoc. When to use post hoc test?
Tomorrow they will explain you again, because this is a testing of hypothesis portion. I just
Just now you told that testing only.
Excuse me, sir.
ask me about describing the data only today.
Sir, excuse me, sir.
नहीं वहाँ तो खा चुके हैं।
Sir, I have a question. Hello.
Yes, one by one,
Sir.
please.
Sir, what kind of data is appropriate to plot box plot, and how
Yes,
it
sir,
can
my
be
question.
explained?
Yes,
Yes, sir. Same question, sir.
Any kind of data you can do the box plotting, but if your data is skewed, box plot is more appropriate. Okay,
sir.
Box plot is very robust.
Hello.
Yes.
I want to have advice from you, sir.
Sir, how to do the post hoc test in SPSS?
Sir, can you explain again
tomorrow
this
they will
box
tell you.
plot?
Sir, how to plot trend line?
Only box plot, sir.
Sir, how can we explain the box plot, please, sir?
Yes, again.
Box plot, sir. Box plot.
Okay. I am just telling you about the box plot. Okay. Just
Okay,
go
sir.
to the graph, legacy dialog. Here you can see one girl is asking that how to plot the trend line. So you can see this. Okay. So when you click on this line, simple line, multiple line, and drop line. So if you will click on the simple line, so it will ask you that what is the category axis and what are the rows. So for this you need the category axis, and for rows you need the year. Because we do not have any year, just I'm putting it the category axis. If I'll click OK, so it will just show you the trend line. Okay. But this trend line is nothing but it is the frequency of 1, 2, 3 like this. Just the age in this like this. Now how to plot the box plot? Again, go to the legacy plot and go to the box plot and go to the simple box plot. Okay, and summarize of a separate variable and then click define. And I'm just selecting this and then I'm clicking OK. So I'm selecting age at admission. Options are there. Exclude case wise, excludes case wise variable by variable. So I am not doing this again. Then I'm clicking OK. So it's just giving me the box plot for age at admission. Now here you can see 1 is the minimum value, and one is the 25th quartile. Similarly, 4 is the median, so this line 4 is coming here, and 12 is the third quartile, or 11 is the third quartile, so this line is coming here. 1, 4, 11. So 25% of observation are above this 11. 50% of observation are above 4, and 50% of observations are below 4. That is what this box plot is actually showing to us. And this is again the interpretation of the box plot. If I will plot the box plot for another variable, simple, define, and instead of this, I am just taking birth weight of the babies in gram, and I'm clicking OK. So here you can see that what is the distribution of birth weight of the babies into this 67 data. So the minimum values is somewhere around 980 gram. Maximum value is somewhere around 3800 gram. The median of this data is around 26. So 50% of the babies are above 26, or 50% of the babies are below 26. 1800 gram is the first quartile. So 25% of the babies are born below. So this is how this box plot is being explained or read off by the reader. I hope I'm clear.
Thank you. Thank you so much, sir.
Thank you, sir.
Sir, I have a request, sir.
Yes, please, Mohammed.
Sir, actually, everybody is asking from a lot of questions from different dimensions. It's getting complicated. Can we follow a order like properly?
Yes, you are right. But today already the session is at the verge of closing. Tomorrow
Right, sir.
onward, I will request the
in the last actually we take the questions.
Yes. Dr. Yadav.
Follow the chat box only.
Dr. Yadav, sir.
Sir.
Dr. D.K.
Yes.
Yadav, sir.
Hello.
Yes.
Please wind up the session, sir.
Yes. We can take the PPT and data set. You can practice, and then we will discuss.
You can ask through the
Sir,
email.
Sir, kindly let us
Are we getting the
track the
recording
trial
also?
version. Sir.
Provide the
We
data set.
aren't able, sir, to
I have
access
shared
the
the
trial
data
version,
set
sir.
to the SPS into the chat box. Data set is there into the chat box.
Send the recording to the mail.
Yes. You will get the set.
I will send all the details through the email.
Okay. So
Okay,
thank you
sir.
so
Okay,
much.
sir.
Thank you so much, sir, for your wonderful session. And
Thank
we have more 6 days, so don't worry. We will cover all the topics. Thank you so much. Thank you all.